their float valves were set. So,
Let me finish up.
That was Beaver. I called him and told him what we had.
Good morning, everybody.
right.
I'm getting everyone in from the waiting room, so we'll get started in just a second. We are going to start very soon because, as you all know, we've got another class right after this one. I want to make sure that we stay on schedule. And then I'm going to give everyone a second to turn their cameras on, get their audio going. And then I'll hand it over to Amanda and Dan to kick us off.
And all those bright faces this morning.
All right, I don't see anyone else in the waiting room, but I'll continue to monitor it. So I will go ahead and hand it over to our instructors to welcome and for Amanda to introduce herself.
So good morning, guys. My name is Amanda Loudermilk. I'm Director of Design and Construction. I think I know most of you, but you guys are my first class. So this is my first time instructing one of these sessions, and I'm excited, but also just a little nervous. So I hope I don't let you down. But it's going to be a fun class, I think. Dan, you want to introduce yourself?
Yeah, so you guys have seen me in two other classes. I'm Dan Martin. I'm the facility manager at Huntersville. And don't let Amanda sell herself short because she is the expert in the construction document phase of this. And I'm on the ride along. So obviously, you guys have seen our cause before. We want to create a healthier future and bring remarkable experience to life. We do that through Discover, Empower, Thrive, and Together. And because we're so restrained on time, we'll just continue on moving. For the housekeeping, as you guys have heard, you want to keep the cameras on. You want to active participate, or we will call on you. Mute yourself if we have emergency calls that come in. Obviously, I know that you guys are all working, so those could happen. If you could raise your hand between Amanda, Lindsay, and myself, we'll catch you if you want to contribute to the conversation. Obviously, we want to engage in discussions respectfully. I know it's kind of hard not to interrupt sometimes when we're doing this virtually, but that's why we want to raise our hands if all possible. And then encourage diversity of thought throughout healthy debate. There is no right or wrongs in this because we all have an opinion. So we want to hear those. And then we will take some breaks, probably every hour for 5 minutes, because we're so restrained on time because of your class at 11.
Can I just get asked real quick, who is the BLH016? I want to make sure we've got you counted for today's class. No one's willing to claim BLH016?
I'll tell you, Yanni will not be joining us today, Lindsay.
Okay, thanks, Matt. All right, we'll continue.
All right. Oh, I jumped all over Amanda, didn't I? She was going to do that. Sorry, Amanda.
Go for it. Do you want to take this one or do you want me to?
No, go ahead.
Okay, so today we're gonna be talking about construction documents, and I think most everybody has been exposed to construction documents, but we're going to talk about what they are, how they're created, what's in them, and our goal today is to be able to identify, reference, and interpret those drawings and the drawings that come after a project is built. So let's start off, I guess, with a quick question of where everyone sits in terms of your experience with construction plans. So I'll open it up and you guys can kind of let us know what level of experience you have dealing with drawing sets.
Matt's got his
I
hand.
deal with drawing sets
Huh.
every day.
Trying to follow the rules with the hand raising, but
Oh, thank you.
I was in construction for 23 years before I took this hospital role.
Great,
So a lot of different construction documents.
great. And I would ask just mostly reviewing them for construction. Have you ever created a set of construction documents or been part of that process?
No, not other than no.
Okay, great. Anybody else? I'm on a laptop screen, so I can't really see lots of hand raises.
No one has raised their hand, but everyone should be able to answer this question.
Justin Willard's
Oh,
got his hand
Justin.
raised.
Yeah.
Hey, so I also deal with the construction documents drawings pretty much every day. I have not really done much on the design or the drawing piece of it. Some years ago, and we have done some stuff through like SketchUp or something like that, where we, show millwork or different things. So.
Okay. Anybody else? Anyone that's never seen a set of construction? Oh, somebody raised their hand. Sean?
Yeah, hey, good morning. I don't deal with them that often, to be honest with you, other than life safety drawings and stuff like that. But my background's kind of law enforcement, so up until 2 years ago, I didn't really deal with this kind of stuff. So it's all new to me.
Oh, great. Good. That's exciting. Okay. Anybody else? All right.
Is there anyone that has never seen a set of plans before?
Brian got his hand raised.
I've seen plans, but is anybody else having issues with their volume? I normally don't have any issue with my volume, but it's kind of hard to hear this morning. Everybody's good? Okay. Sorry. Thanks, guys.
Yeah, Steve is saying his mic had stopped working on his laptop. So
I can yell if it helps. All right, well, great. It's good to hear a varied level of experience because we're going to go through quite a bit. So go ahead, Dan.
all right. So what are construction documents commonly referred to as CDs? Basically, they're detailed information about the facility's design, construction, and operation. They could include, the blueprints or the plans, the blueprints, drawings, sketches, the specifications, the submittals, diagrams, elevations and sections, 3D models, shop drawings, and probably everybody here on this, the most we've ever been involved probably is the blueprints, drawings, and some of the shop drawings, and the work that we do most every day.
So why are our construction documents important? So when we talk about construction documents, we really are talking about that final set of documents that go into building any sort of structure. And the CDs communicate design intent. They ensure clarity and consistency for the project. So the construction team knows what they need to build, and the more detail that's in them, the better, the fewer questions we have. They guide that construction process from beginning to end, making sure that we are following all regulations, all codes that are required. And then after construction is complete and the building is in operations mode, these drawings will serve as a record of what was built. So if you have issues in your building, you can use them to troubleshoot and resolve problems.
Matt's got his hand raised.
Yes. Matt.
Matt,
did
can you
have a
hear us?
question?
Sorry, I didn't mean to raise my hand.
Okay.
Okay, good. Good.
Good one, Matt.
Good one. All right. So, like I said, when we were talking about construction documents, we're talking about that final set of documents that we use to build from. But construction documents are really a process. We don't start off with, hey, you know what, we want to build a building and go straight to very detailed drawings. We have to go through a process of understanding. So typically what you will see as we're working through a project, particularly design, we will start off with what we call schematics. We'll move to design development and then ultimately get to the construction document sets that you all, or some of you are aware of during construction. And at each level, they increase in detail and understanding. This is a handy dandy graph of a typical project sequence, and it's tiny print on there. So if you're on a laptop like I am, it's hard to see, but you can see in the design section of the project, there are those 3 distinct phases where we create those 3 distinct sets. Now, depending on how large the project is, those phases and those sets may morph a little bit, but the general idea is when we start out at schematics, we have a really good idea and not a lot of detail. And as we move through the process and get to construction documents, we still have that really good idea, but we've got lots more detail wrapped around it so that the drawing set that comes out of the CD phase is much more detailed.
Yeah, and as Amanda just mentioned, the early on, the schematic design area, it's that high level bird's eye view of the project. There's not a lot of detail that she mentioned. So we're kind of not worried about, the millwork and more detailed information like that. Typically it's wall placement, door placements, that kind of is at this stage.
And then we formally moved to design development after schematics, and design development is really about continuing to add detail. So while Dan was speaking about schematics, we made sure we had all the rooms in the right place and everything was placed correctly. In design development, we start to formalize where the walls and the doors and what the dimensions are. We start to really think in 3 dimensions about what that elevation of the building looks like, and start to really think materiality and what's it constructed of, and how does that translate into a building construction style.
So when we're looking at the deliverables for the design development, we're looking at possibly involving the contractors, depending on the size of the project and complexity of the project. You could look at the HVAC, electrical, plumbing, those trades there. And we also are looking at some of the deliverables could be meeting minutes. As we're meeting, we're making notes. We want to make sure those notes get transferred onto the designs. With those notes, some issues could arise. So that would be into the decision-making process. As Amanda mentioned, we've already got the walls kind of in place, making sure the space program and comparison is happening. If we're doing an OR, it's at the correct size. Then we're also looking at FGI guidelines, just making sure we're following those. And then we've got the mock-up drawings, the sign-off package. That was real big into a project that I did here in Huntersville back in 2012 with the first bed tower. We kind of designed it. All the departments got together. We signed off on the design before they moved into, the final stages. And that's where the renderings and the presentation of the images kind of were made, was, to the interdisciplinary teams.
And so typical drawing types that you will see in a design development package, I think in schematics, you see similar types of drawings, plans, mostly in schematics, and narratives for MEP. In design development, you start to have a lot more specific and a lot more in terms of number plan types. So civil gets involved, architectural, structural. We start to have mechanical, electrical, plumbing plans, some diagrams. a special systems low voltage plan, which we'll talk about, I think, in detail later. You get a lot more information around the interior, start to have some interior finish plans, elevations. We start developing specifications, so those will get generated for a formal design development package. And then engineering is really starting to add levels of detail for decision making. They typically, on large projects, we will do energy optimization reports, analysis. We'll do equipment life cycle analysis, acoustic assessments, and light level assessments to help, refine some of the decisions as we move into CDs.
All right. So when we get that package, that CDs, this is kind of like, I use the word final, but I use it loosely because we all will find out that nothing is final when you do construction until the last nail is driven, so to speak, because you'll run through changes. But when they present this, it'll be the plans, those blueprints, the details, be some of the millwork details, you'll be able to go to the elevations and see that information, and then diagrams. I just talked about elevations, so we get the 2D verticals. You'll see what the inside rooms look like a little bit, and even the exterior of the building, what it's going to look like. Then we'll get those specifications. And depending on the architect and the size of the project, you may even get a 3D model. I have not been so fortunate, but I've never ruled it out. And then also with some of that, you could also get submittals that you got to work on.
Okay, so I get to speak to you about our Novant Health design and guidelines and engineering standards, which I'm very passionate about. So we do at Novant Health, we have, on top of all the regulatory things that you and our teams have to comply with, FGI, Facility Guidelines Institute, all the NFPA, all the building codes, just the list goes on. Novant Health also has some standards and guidelines that we want to ensure we consider during all these projects. And I can get into the philosophy of why, but that might be another presentation. How do you get to these guidelines so that you and your team can understand what's in them? The easiest way to do it is on ATG. We have them stored there. The facility drawings, so you all, I think, know how to get to facility drawings. But the guidelines are stored under the resources section. So when you go into ATG, you select the site-specific info bar. For me, it's up at the top. And then under that is resources. And when you click there, you'll see a list. There are other things in that file structure, but we try to name them all Novant Health Guideline, or Novant Health Design Guideline, and then there's a series of names after them. I think there are 5 in total that make up the entire guideline. So if you would like to access them and just sort of see what's out there, that's the best place to go find them. So this is the introduction to our planning principles, or not the introduction, but the table of content. Just to give you a quick idea on this presentation of what is contained in some of these documents. So the planning principles is really about those big ideas. So when we're at that conceptual schematic phase of drawings, what kind of information are we needing to consider? And it really is high level, but it goes through things like flow and adjacency and all that kind of stuff we have to figure out early on, so that as we move through that project and get more detail, those things are figured out. There are some more detailed information in the planning guidelines around some architectural and interior components that we just want to make sure our architects grab. So I highly recommend it's an easy read. It's lots of pictures going through it. And then this is the contents for the signage guidelines. So like I said, there are 5. There's the planning principles, there's the signage guide, there's interior specifications, there's our ambulatory clinic guideline, and then there's the engineering standards. And so you can see the level of detail we get to with the sign guideline. We don't typically put our signs on our construction documents, but this is important information to know, particularly for anyone who in our facilities, you guys deal with signs regularly. So there's a guide out there to help you. All right. So we're going to talk a little bit about design team structure, simply because when we're creating these documents, it's really important at the beginning. I think Dan talked about in schematics having, his project that he worked on. There's an entire team of people that have input into the documents as we move along. And so, and this can be found in our planning principles. So, if you go look, you'll be able to see it and read it. For every project that we're creating documents for, regardless of size, we're going to have some sort of project team that is involved and some sort of decision-making or decision-making module, right? We've got to have someone who's going to approve the drawings, someone who's going to recommend information that goes into the drawings. We're going to have a ton of people we're consulting with. Occasionally we'll have people on the team that we're just informing what's happening. And then we have folks on the team that execute. Those are typically our project managers. This is called the RC model. It is a model that Novant Health has historically used to make decisions. So depending on your project size, this could be very complex or very simple. If you're working on a small equipment replacement, say in imaging, your approver is probably going to be your departmental manager or director, and your informed person is probably going to be our facility president, right? Like, we've got to replace the equipment. They're the people who know best what needs to go in there. In that situation, our consultants are our design teams and DPS and all that stuff. Is that clear? Yeah, I was gonna say RC is a weird, just to follow up. It's something you have to think about every project, right? Like, the team members will vary. And then also in the planning principles is this document around just team structure and the number of people that can be involved. Again, depending on the size of the project and the size of set of documents that we're trying to create, this team can vary in size. Large, big, new greenfield hospitals are going to have every single representation from every single one of these groups. Small facility-based replacements or renovation projects may have, just a few of these groups represented. It's really dependent on size of project.
All right, so we'll continue on with the engineering standards. Wow, it's early in the morning. So with those standards, we've broken down into 7 sections. The first one being general, and that's kind of our policies and procedures area. So if you're looking at that, it could be the hot work permits, the above ceiling, those ILSMs, ALSMs, those items there. And then everything after that is kind of self-explanatory through the plumbing, the HVAC and electrical systems. Section 4 is fire suppression. 5 is the special systems, low voltage, could be nurse call. And then you got special systems cabling. That's definitely nurse call, and then you got the conveying systems in section 7. All right. All right. So, let's see. I'm lost. I got lost here. All right, here we go. There we go. All right. So, specific requirements. So this would be an example. So if we got new equipment on the drawings, you think about air handlers, the minimum and maximum outdoor flow, that's going to be, with these documents. So we're drawing these things out. We want to make sure that we're outlining, and we'll get into a little bit later on how we do that. But these are just kind of examples of the engineering section. So we want to talk about pressure relationships. Obviously, if we have isolation rooms, if we have ORs, we want to make sure that they're in the positive. And if we're doing air handlers, we want to make sure that the information that we're relaying is correct. We don't want to make an OR negative by any way, shape, or form. So we want to show, everything on these drawings, volumes for these VAVs. Obviously, if it's an OR, we want to make sure it's, a constant volume. If it's just a regular patient room, it will probably have some outlines on the airflow, the minimum and the max. We want to have access doors to all the chases where we may have some fire dampers. And then, on the drawing also, we'll look at, pipe diameters. We'll kind of get into this in just a minute. All right. So again, once again, these engineering designs, we can get into automatic temperature controls for HVACs. The components, they're clearly defined and require a sequence of operations, and that's important. We just did an air handler up here in Huntersville, where it was kind of a supplemental, and I did not have the sequence of operations, and that kind of really limited me on the knowledge. So having that, and if we would have followed the guidelines, which we didn't, they would have been a lot easier. So they can make it a lot easier for us when we're doing these projects if we just reference these guidelines. And we just touched on just the engineering standard. And remember, there's 7 total standards, and you just want to make sure we're addressing them, especially in the smaller projects, which we may not get a lot of people on Amanda's level involved. We may just keep it just at the facility level. And as I mentioned, the design consultant, they're important. If you don't recognize them, that you could get those special systems and things of that nature mislabeled, not done to our standards. Recently, we have talked about nurse call here in Huntersville in our restrooms in the ED, because we're not going to follow the design standards because we've got an upgrade coming. We made a temporary call. So that kind of comes into budget a little bit too. But you also look at the design standards fall into the TVs. You've got cable TV. Card readers are huge, so you got to involve public safety along with the cameras. The paging system, which I think we kind of both own between public safety and engineering. We seem to be the ones that repair it, but and they seem to have it and everything in the SOC. So just make sure you're referencing these drawings and these requirements that we have kind of helped kind of develop for our protection.
So Dan makes a really good point. We have a lot of groups at Novant Health that have a voice. So when we go back to that project team, all those groups have a voice, and the whole role of these CDs, our standards, all of that is to pull all of that information into one location and make sure all of those groups we've consolidated all of that into one space. One of the most important things that we have to do is room naming and numbering. This is a standard that is created by DPS. It is not a design and construction standard. And particularly on large projects, but I would say on every project, a lot of thought needs to go into room naming and numbering. And we have a policy on it, particularly for patient care areas, how it relates back to Epic. Most of you probably know, though, room numbering also relates to fire alarm and other building system requirements. So it's really paramount that we get it right on the drawings so that we don't have to redo it in the future and cause a lot of pain and sorrow. So the room name and numbering are not in our design guidelines, but we reference the policy and highly recommend, if you are managing any sort of project or any sort of document creation, that you spend some time with your design consultant to get this right. this is me. We're going to talk about individual drawings within a CD set. So we'll explain what the drawings are and what you'll find on each drawing type. So first and foremost is the title block. It is on every single drawing. And there are, there's lots of information in the title block so that we know, who drew it, when it was drawn, where it is. We know what revision we're on, etc. The page number is at the bottom, depending on the size of your set. These page numbers are extremely helpful in understanding which section of the drawing set you're in. So every number at the bottom of the drawing set starts with a letter, and that letter lets you know what section of drawings that you are in. And there is a preferred order of those. I think we get into that. If we don't, we'll go through it informally. But after the letter is a number, and that lets you know what drawing number you're on. So title block is on every drawing and chock full of information.
We do go into the nomenclature a little bit more, but you can see on this slide the preferred order that the drawing should be in, starting with the cover sheet and ending in operations.
Yep. And as Lindsay and Amanda referenced, the title block right there at the very bottom, that's where we get our letters. And obviously the G is a general. It's kind of general information. And if you can get into the A, it would be the architect. The C would be civil. And they're not always single letters. I've referenced like the LS is life safety. So they are very helpful, especially when you're trying to find those particular drawings that you can thumb through them really quick. Then the next one is the sheet type. And then you got the sequence number. Usually in the center of all that is it's divided by, the period there or the dot, whichever one you want to reference. But I highly recommend, at least knowing the lettering that would help you kind of navigate through the drawings a little easier. For instance, the mechanical drawings will be M, electrical drawings, the E. That way you can kind of jump right to those sections fairly quick.
The other thing you'll see a lot of in a drawing set are legends and keys. And these are extremely important so that we can, again, we're consolidating information, right? If you were to look at a plan and there was a note for every single thing, it wouldn't be a drawing anymore. It would be a bunch of words and descriptions, and it'd be very difficult to understand what's similar and what's different. So legends and keys, or legends and symbols, really help to consolidate information and make it easy to understand. Each symbol represents some element of construction. So they can be materials, fixtures, components, it can be whole systems. And it can be a useful tool for identifying different parts of the drawing set while you're doing construction, but also after construction, when we talk about our record drawings, being able to quickly identify where you go to find information in the drawing set and what that is.
All right, so how do you use these? Usually they're located like a table of contents right there at the very front of the section. For instance, the HVAC that we're looking at here, if you look at, you'll see a symbol, and then just to the right of it, you'll find a matching description. And then when you reference the plans, those symbols will be on the drawings that kind of show you exactly what that is. And it's a nice reference back and forth. All right, so we're going to go to an activity. So we're going to reference the Matthews Medical Center mechanical drawings 0.00, and we're going to use the legend on the left, and it's going to be kind of difficult because we're going to kind of tag back and forth because I think our example doesn't show color. So what we want to do is we want to locate both the supply and the return on the drawings.
Does anyone not was anyone not able to download the drawings from Hightail? That's going to be important. Does anyone need a second to access those and download them?
Yeah, I haven't even tried yet.
Okay. Awesome,
Yeah, I
thank you.
haven't tried to.
All right, I'm going to pause here, give you a couple minutes just to make sure you've got them. If you can just give me a thumbs up whenever you are able to open them up. And right now, just worry about the mechanical set.
Yeah, and if you want to kind of take a quick note, on the legends, the exhaust is pink, supply is green, and return is blue, and outside air is yellow, just because I know that's not color coded on the drawings.
And I'll share my screen in a second. I just want to make sure everyone's able to at least open the mechanical set.
Which one are we opening? Which attachment?
The mechanical set. So
mechanical.
you would have received a email from Hightail last night, late. So it came from Hightail. There will be 3 PDF attachments to that. All of them are Matthews Medical Center CDs. And right now we're just going to open the mechanical set. And when you have the mechanical set open, just give me a thumbs up. Matt Daniel first. Justin. Gary, got you.
Melissa, she's got thumbs up.
Thank you. Brian, got you.
This is Steve. I got it.
Thanks, Steve.
Dang, you got volume.
I'm
Well, I
up.
called into my phone. I forgot you could do that.
No.
Sean, you got it? Yeah, okay. Kimler got it. And then Seth had to step away, so we will proceed.
All right. So if you've got them open, you'll notice that M000 is the legend page. And I know that my eyesight is pretty bad and I really have to blow these things up in order to figure things out. But then if you tap down, just use the arrow key, you'll go down to the next level. And there's your plan. And Lindsay has got the color codes up. So we're going to reference the supply. So everybody finding the supply error? And that would be in which color? Green, exactly. And then if you reference the return error, you see how that's outlined. And that's in what color?
Blue.
Exactly. And then I know it's not one of the questions, but the exhaust error, if we look on the drawings, you can see where that is in which color.
Pink.
Pink, exactly. So, I've referenced this here recently in our lab drawings, and unfortunately, I did not have all the color codes, which would have been very helpful because, when I was outlining ours, all I had was RA for return error, SA for supply error. And when you get all these lines kind of overlapping, they kind of really get a little busy. So if you can reference the drawings that have the color codes, I would highly recommend it. It'll save your eyesight. Any questions? All right.
Okay, so moving on to door schedules. Schedules are extremely useful tools to consolidate a ton of information. And one particular example is a door schedule. So you can imagine on any large project, the amount of doors that you have in the facility. A lot of them have very similar characteristics. So all office doors are going to act and function in the same way, and probably be the same size and all that stuff. So the door schedule is really meant to consolidate all door information and hardware into one location. This sheet from, I'm not quite sure, Matthews Medical Center, shows not only the door schedule, which is obviously got a revision at some point, it's bubbled in red. It also shows all the door elevation, all the door type elevations. It shows all the frame type elevations. Those are on the second row. And then, well, second, third, fourth, fifth, and sixth row. It shows you all the frame types that will be in that project. And then there are also some details that are cut through the jamb of each door type, so you can see what kind of frame that it has. I think our next page talks about how we read the schedule. So schedules are really basically a glorified spreadsheet. They have, they read just like a spreadsheet from left to right. They have headers that help you know what you're looking at. The key is to find the right schedule first. And so you can do that by going to the content sheet of a drawing set, finding out which section it's in. It's usually in the architectural section, which number set it is, find that drawing. And you basically can use the top header row to find out what category. The doors are always listed by number on the left, and they correspond to a number that's on the plans. So on the plans, the doors will have a specific door number. That door number is in the far left column of this schedule. And then as you read across, you can see, I can't read it, but you have size of door, the material of the door, frame type for the door, the head detail, the jamb detail, any special information that you need to know, hardware type. So similar, we group hardware sets into groups, and it'll usually give you which set of hardware goes on that door. So it's a real quick way to find information about every single door that is installed or meant to be installed on a project.
All right, so we've come to a break time. We're doing pretty good on time. It's 8:43 according to my lower clock. We'll take 5 minutes and we'll come back. So let's try it 8:48.
Lindsay, do I just get started? Perfect. Okay, welcome back, everybody. Lindsay and team made this little video. I'm gonna let it play and then we'll talk about call outs and schedules. There was music, but I don't think you can hear it, so I could hum if it helps. I won't. So the video is pointing out circles, they're call outs. These are elevation call outs on the drawing. You use the number in that bubble to jump to the sheet and the specific drawing. And so you can see that's an elevation of some millwork at a nurse station. And then schedules, we talked about this a little bit. She is so the schedule was what we talked about, outlined the door name that you got from the door number, or the door number that you got from the plans with the number, and then the information to the right. Call outs come in various forms, just so that you're aware. They show up on plans mostly. So those circles with the triangles on them are pointing to a view. So those types of call outs call out elevations. When you are looking at an elevation, there will be a section call out. And so it's a line drawn through, because sections are really cut throughs of certain areas. That call out will have an arrow also showing you which way you're looking at the section, and it works the exact same way. The number of the sheet and the call out is in the bubble, and you jump to that page and find that drawing.
All right, so we're going to jump to plans. We kind of touched on these a little bit. So the CD, obviously, when we talked about deliverables, we talked about these plans. These plans will include, the civil and structural. Civil is usually C or CS. Architectural, or in the structural, is S. Then you go to architectural, you get the demolition plan, which is always my favorite. Then you get the reflective ceiling type. Then you got fire protection, and you'll jump into the MEPs, which could be the the mechanical, electrical, plumbing, and then we got the low voltage.
So I'm going to talk about a specific plan, but I think it merits saying that every drawing that we're looking at in the construction documents is a two-dimensional plan, right? So plans are 2 dimensions from a bird's eye view. Civil plans really are from up high. They do not cut through anything. And so in a civil plan, you will see information that pertains to the site. So you'll see where the building footprint is. You'll see parking. We will outline utilities and where those go, underground, drainage, stormwater, all kinds of information goes onto civil plans pertaining to the site.
So once we jump to structural plans, that's where you're going to start seeing those detailed layouts. So the foundation, some load-bearing walls. And if you remember back in the project management class, we talked about a scenario with a cooling tower, and the weight was being too much. This would be a great, reference in regards to that, if we run in that quite of an issue. You can use them for smaller issues if you needed it, but they're also very good. I know Steve is very familiar with one in the Matthews program, like we're referencing today, with a nice little shear wall that's going right through the middle of his building. So.
And then, of course, there are architectural plans which show how spaces in the building align. They show where the walls are. When I was talking about civil plans being more of a bird's eye view, an architectural plan is actually a section cut through the walls. So you will typically see on the plans, the walls are a bit darker, or they're called out as being cut through, and you're really looking at the floor as if you've cut straight through the building. Architectural plans can show you all kinds of information. And this is where we really address a lot of code requirements around fire safety, accessibility, any FGI guidelines around clearances and that sort of thing typically get shown in our architectural plans.
And as I referenced just a little bit ago, my favorite, the demolition plans. We get to break stuff up. So they could be like the architectural plans, just outlining where we are taking out walls, where we're taking out equipment. You always want to make sure you're looking at this at a very high level when you start the project. For instance, when we started in 2017 at Huntersville with our bed tower expansion, one of the things that we had to do because we were adding onto the building was remove brick. Well, nobody thought that was going to be an ordeal. But with brick comes vibration because you're going to use hammer drills. Now with the hammer drills, you got noise. So those are all kind of things to consider once you start looking at this demo plan. And it will show you method of demolition, safety measures. Obviously, we're taking brick off the building. We definitely going to have safety measures. We're four stories tall. And then also the disposal and how to keep everybody, safe in that process.
And then there are reflected ceiling plans, which are basically a version of an architectural plan. But instead of cutting through the building and looking down, you are cutting through the building and looking up at the ceiling. This used to confuse me when I was starting out because I was like, but if you're looking up, then that plan's going to look a little different. You're just taking a mirror of the floor plan and what would the ceiling look like above. So in reflected ceiling plans, we can show all sorts of things that happen on the ceiling. We can show lighting locations, ceiling grids, ceiling types, ceiling heights, locations for diffusers, any HVAC component, anything that has to do with the ceiling can get shown here. Just to be very clear though, things like HVAC components are detailed out, and lighting are all detailed out in the electrical drawings. We don't put the detail here. These are location only.
All right, then we're going to jump to the life safety plans, which I think everybody here is quite familiar with. Obviously, these illustrate the building safety features, fire rated walls, emergency exits, fire protection systems, exits out of the building. So this is, obviously something that we want to make sure that we're addressing, especially if you're adding on to the building. Because if you're adding on to the building, you want to make sure you're reviewing the current signs, making sure that they're pointing in the right direction, just not the new. So, make sure you're addressing the old just as much as you are the new.
And then we're going to start to get into some engineering plans. So mine right now is fire protection plans, but for all of these, just know that the architectural plan is the underlayment for all of these. So if our architectural plan changes, this is particularly relevant if you're involved in a design project. If your architectural plan changes, your consultants need to know that your architectural plan changed because they have that base drawing. Most are pretty good about it now because we're working in 3D and we're trying to work in a model altogether. But if that base plan changes, all your drawings for engineering are going to need to change as well to reflect the change on the architectural plan. But fire protection plans provide you a layout of fire protection systems, so sprinklers, fire alarms, fire suppression, etc. You can use these in coordination with life safety plans to ensure that we have clear egress paths and emergency exits. And then, in the record drawings, post a project, you can use them to locate and maintain fire suppression systems, smoke detectors, fire hydrants, and emergency exits.
So our mechanical plans, obviously, there are HVAC systems, our air handlers, the designs and the requirements around that. What I've used the mechanical plans for, pretty much almost all the time after construction is for maintenance purposes. We used them a lot when it came into COVID because we actually had a lot of rooms that we changed the VAV settings. So, and we talked about schedules a little bit ago. When we were changing those VAV schedules, some folks did not write down what the original settings were. So we had to refer back to these plans in order to get to the proper settings. And that's where our plans really helped us, the scheduling, and understanding that airflow and making sure that we got back to where we needed to, because obviously each room has a requirement. And so that way we were able to kind of put things back normally at the end of COVID. It also kind of helped us with, some issues that we ran into the past with the linkage on fire dampers that were breaking. So it kind of outlines where those fire dampers are. So we weren't walking all over the building trying to find them. We knew exactly where they were. We knew where the problem was. So we could go right straight there. So they're very helpful in the mechanical or in the maintenance side, not only just in the construction side.
And then you can probably guess what electrical plans are. They show our electrical systems, including power locations, both normal and emergency. Those will show up on a standard architectural plan. We also show lighting, which uses the reflected ceiling plan to show locations there. Sometimes you will see things like data outlets on power plans, and we will talk about that in a drawing come up. It's perfectly normal and acceptable to have data locations on your power plans, depending on the size of the project. But we'll get into a little more detail about that too in a second.
All right, so we'll jump into plumbing plans. Again, very useful on the maintenance side, not only on the construction side. We definitely were going to be looking at water supplies, making sure that the water is going in the right direction, and whether it's hot or cold. So that comes into the temperature relationships, whether it's heating or domestic. Drainage systems, if it's just a regular sewage line or is it a roof drain? Then you got your gas lines, your med gas, your vacuum, your oxygen, that's all on there. And then also with the plumbing, if you go to the water supply side, you get these circuit setters, which could be very helpful in locating just for balancing the water, making sure you have that balancing throughout the entire building and as you move forward.
Okay, and then this is my favorite drawing ever of all times. Low voltage special system plan. So like I was saying on electrical, it's been perfectly acceptable to put data networks on your electrical plan. But here at Novant Health, we go back to that team grid. We have a ton of people who have input around devices and different systems that go into our buildings, particularly low voltage systems. So our public safety team determines our security and access. Our infrastructure team does nurse call, and cameras and that sort of thing. And then, different end users have TVs, and nurse call is its own thing. And so all of that is decided by different people. And we have one vendor who does all of our cabling. And our consultants typically do not do low voltage design in and of itself, which is a whole nother thing. So what we do like to provide as part of our plans is a combined low voltage special system plan. And it really does typically uses the architectural floor plans, just like the engineering drawings. And we locate every single low voltage device system that we have talked about and decided upon as a team on that drawing, so that it is all together. And when they go in to do the cabling, or we pass it off for actual real low voltage design of how many thingies come through each port, then it's all there on one page, and it makes it a lot simpler. This is something we just started doing too, like within the past 2 years, and it's helped tremendously.
All right, so we'll jump into diagrams now. So the first one on the list is single line diagrams. you'll normally see these with some, plumbing, some piping layouts, some heating, some cooling. It's just a simple way to show the layout of the piping and the MEP systems. And it will also not only go horizontally, but it will show as a riser in the vertical situation. And then if you jump into the schematics, they have a little bit more detail to the drawings themselves, with the HVAC, the plumbing, the electrical. So you'll see those system functions and sequence of operations here also.
Okay, I get to talk about elevations and sections. Just a quick overview real quick. We've been talking about plans which show length and width basically in 2 dimensions. The elevation and section are also 2D drawings, but they show height along with maybe width. We don't get depth. So this is the first set of drawings that will actually start to show us what this building looks like in 3 dimensions. Elevations are similar to a civil plan, a bird's eye view. They're a long range 2-dimensional view of a surface. You see these particularly for the exterior of buildings. We have whole building elevation, so you can start to see materiality of the building. You can start to see heights and how they correspond to other areas of the building, but really give you an idea of what it looks like from afar in 2 dimensions. We also have elevations on the interior as well. We're just not seeing examples. And then sections are cutaways through those elevations. So the only section on this drawing is the one of the stairs that show you going up in height. The other 2 are plan details of the stairs. Sections are extremely helpful drawings because they really tell you the detail of how something is constructed. An elevation is a pretty picture that shows you the materials, but the section tells you how those things go together to build whatever it is that you're looking at in elevation.
All right, specifications, that's me. All right. So we talked about a little bit already in those specifications. These are descriptions of our materials, products, standards during the use of construction. They could be quality materials, types of materials, and what they do is we ensure that we're using consistent products. And if you go to our engineering standards, a lot of that stuff is outlined of what we're looking at. Especially when it comes to furniture, we have a certain fabric that we're looking for. Sorry about that. One thing I can't silence is my desk phone. And how we do those are through some we don't normally see it, but it's CSI codes and standardizations. And this kind of helps the architects, the engineers, the contractors, the suppliers, and making sure that they've got things. In doing that, you can see it's broken up into divisions, and those divisions are broken up into kind of like groups or sections. So if you were referring to Division 4, that would be all the masonry products. Division 12, that's the furnishings. If you go back to 16, electrical and lighting. So that kind of helps those groups kind of make quick references. And then if we go to shop drawings, you think about shop drawings as, we talked about elevations. Think about your room being broken down that maybe have some millwork, some cabinets. For instance, I know Steve is probably doing an OR right now, and they have probably broke down every single cabinet that they want in the room and what it looks like. So what it looks like, we have to translate that to the people that are actually, doing the work. So that's where our shop drawings come in. And that's more of a, something that's going to be done by the supplier. Sometimes the contractor has a little bit of input on that, but the person doing it usually is the one that kind of develops their own shop drawings in my future, in my past. All right, so submittals, we talked about a little bit already, But you can think about the submittals as a high level. Early on, it could be your concrete, the PSI level. It could be, whatever kind of mixture it's going to be for your like your shear wall. And it can break down all the way into, your plumbing fixtures. For instance, in one of our projects here, we were shooting for those Chicago faucets, and plumbing fixtures. Unfortunately, Chicago was running through some issues that we weren't allowed, to get the quantities that we were wanting. So we had to kind of look back and do that evaluation, and we moved to TS brass. So that was something that was changed early on in the project, just because, when we were in the planning stages, we reached out and we realized we couldn't get them. So it definitely is helpful, and to retain this information. It will also help you with these submittals with manufacturers, maintenance, parts, all these data sheets can help you in the future for maintenance reasons.
All right, I get to talk about 3D models. And before we move to the first slide, I just want to say 3D is so exciting, right? So an entire set of documents is 2 dimensions. We talked about that over and over and over. And while you get a lot of really good information about that, 3D is just next level. It puts all those dimensions together. 3D models have been around for a long time. They typically have not been used in construction documents because the old way to do it was by hand, and it was very complex. Plus, I mean, architects would make these beautiful cardboard and stick models to represent the building, but there wasn't a whole lot of detailed information about how you actually built it. So today we have BIM. So we can go to the next slide. Building information modeling, which is really advanced 3D software. It's built into just about every architectural package for drawing. Revit is a specific one that groups today are actually, they're drawing in 3D. They are drawing the building in 3 dimensions as they work through figuring it out. The benefit of 3D, right, is it gives you more information in real time. So once you start to pull that 3rd dimension up, it happens simultaneously, as opposed to trying to draw in 2D and detect clashes from page to page to page. You can do it in one model. What's interesting about 3D, I think, and we'll talk about this here, but what's interesting about 3D is we draw it in 3D, or they draw it. I don't draw it anymore. They draw it in 3D and still cut 2D sections to represent to contractors, which I think is an interesting concept. So what you're looking at here, I believe, is the 3D model of, I think it's the Forsyth Medical Center central energy plant we just did. And it looks like one comprehensive model, which is great. It's actually multiple trades, multiple models, and they combine them into one to get this comprehensive understanding of how all those systems work together. You can tell if you start putting things in 3 dimensions and you got a pipe running through another pipe, there's a problem. And it's much easier to see when it's all together than if you're looking at line drawings or 2 dimensions at multiple sets of different disciplines. You start to get a whole picture. I'm excited about 3D. I get very passionate. This is how I started my career, was doing 3D models, and just the concept that as we move, the construction industry moves and gets more advanced, that one day we may not have paper sets or PDFs of plans, that we might be building directly from computer generated 3D models. Some folks now are even printing from these things, right? So you're printing walls from these models, which is pretty exciting stuff. Okay, I'm gonna pause and just make sure there aren't any questions. We're gonna get into closeout, but when we talk about drawing sets, go ahead, Dan. Were you gonna say something?
No, go ahead.
Sorry. Just make sure that we clarified any components of drawing sets. Okay. Dan, we did an amazing job. Look at that. All right, so we'll
I
talk
have a
about
question.
closeout. Oh, go ahead.
have-
Sorry.
Um, so what's the goal of this class? Because I don't feel like I'm gonna get a handle on it after just an hour or an hour and a half. Is it just to kind of get a brief overview of what we're learning? Because if somebody would have quizzed me right now, I'd be like, I'd give them the lost look. But is it just a big overview of what kind of goes on?
I will answer what I think. I think the idea is to give you guys as future leaders a bigger understanding of what goes into construction document set. I have tons and tons of sets of documents. If you would like, we can go through in detail and figure out, where the questions are, and to whatever level detail you want. But I think the idea is just a broad understanding, so you know what you're
Okay.
looking at.
And that's fine. Thank you.
Yeah, just an introduction, so to speak.
Okay.
We are, we will reference both guidelines and the engineering standards as part of the homework assignment. And if obviously if you have any questions as we're going through the scenarios here in a little bit, we've got 4 scenarios, so you actually get practice flipping back and forth. So that, again, that's why I sent those other documents out. We've got an architectural one with doors, and we've got one for electrical systems. So we're going to practice using those drawings, and your homework will give you more practice referencing the standards and the drawings. And then here in a few weeks, we've got another class called construction drawing reviews, where we will again go back to some like blueprints, set of drawings, and compare those against FGI guideline standards. So you'll actually see, does this design, as it's currently illustrated on the drawings, is it in compliance with the FGI standards? So you're going to get more practice than today, but we had to start at the foundation and build from there. In the class that we have next, you're going to get exposed to different construction forms, mostly related to risk management. And then this afternoon, Amanda and Matt are going to talk about construction management. And that goes into what we're about to talk about with closeout drawings, but so much more than that too, like different contract types and the bidding process and who the project team is made of. And it's a lot, right? It's like a full day of construction. And then we're going to do like another several hours here in a few weeks, again, back in drawings. But I would encourage you, if you have questions and you're like, okay, I got maybe like 10% of what we talked about today, I would like more practice, and this is how. Let's talk about that, because this program is designed for your benefit. And if you feel like we need to spend more time or slow down to refocus, what we're doing here, let me know. And we'll modify, how we're spending our time.
I will add, and I don't know, I mean, we can work with Lindsay to figure out what that looks like. The easiest way to understand a set of drawings is to sit down with a set of drawings and flip through them and ask questions. And I mean, online it gets you kind of aware of what we're doing. But drawings do exist in a set, and that's just the easiest way to comprehend them. So we could probably talk about what that might look like.
Yeah, and to Amanda's point, you'll find out that it's probably a little bit easier with the big set sitting in front of you rather than the digital, because it's easy to use the match lines and go from drawing to drawings when you're doing overlays, or you've got different floors that are involved. So definitely, if you can use a hard set, it's definitely easier to do it that way.
Which is why the switch to 3D is so exciting, because it's so much easier to see 3D digitally and less on paper. And so you're kind of in this transition phase right now with how we document construction. Exciting stuff.
Yeah,
All
old
right,
people
so-
like me only had the paper drawings.
Nice. All right, so closeout documentation. So we have we've created our construction documents. We have built the structure, building, room, whatever it is that we're going to do. At this stage, we have to transfer it over to our operations team and make sure that they have all the information that they need to operate the new space effectively. So we really try to think about transition to operations while we're constructing. So
So your closeout documentation is very important. Definitely make sure you get your closeouts, because there's those red line drawings. This is where everything gets transitioned. So any changes that happen during the construction are noted on the closeout documentation. And that could be, on your plumbing plans, your HVAC plans, even your submittals. If you decide that you change faucets like we did. And then also they will, as mentioned before, those asset manuals, preventative maintenance procedures. Those will all help you without, that you're presented with this closeout documentation. So make sure you push for that. It's not always something that is done right after the project is over. We've got them as far as 6 months after the project's over, simply because every group has to hand in their red line drawings, and then they have to be all transferred over, and all that documentation has to be collected. And so just don't forget about it. It's very important.
So some specific closeout documents that you will be looking for. So a test and balance report, which is basically a report that ensures our HVAC systems have been tested, balanced, operating as we intended them to. Operation and maintenance manuals, which give you comprehensive information about materials, equipment, etc., and how to operate and maintain. And then that we have as-built drawings up here, but you as facility folks will not receive as-built drawings, because as-built drawings go from the contractor back to the architect. You all will receive record drawings. So the architect takes the as-built drawings and they incorporate any red lines into not only the hardline version, but a CAD version as well. And those record drawings get published on ATG, and get sent to the facility. So so preferably if you are looking something up, you have an issue at the facility and you need to find something, you're going to be using the set of record drawings.
All right, and some other closeout documentation that you're going to be looking for is, we talked about that user manuals for all your stuff on the submittals. As Amanda mentioned, your record drawings, not the as-builts. I've been corrected many times, and I still call them as-builts to this day. Sorry, Amanda. Your CAD files and DWG files, those are the ones that you're probably going to send to ATG to make sure that you get all that documentation translated, so that when you're looking up your life safety plans or any other documentation that you're accessing ATG for, so that it's in there and it's correct, especially if Joint Commission arrives. Your warranties, basically, one of the things that I've referenced is my roof warranties. They always seem to come into stock. And then your attic stock, which is going to be your extra material. It could be flooring, it could be, fixtures. It could be anything that you're going to use later on that, because they're always, I think it's a 5 to 10%. They increase in order. And then your maintenance information and training sessions. If you're getting a new air handler or you're getting some new equipment, you definitely want to share with your team all those training documents. And you may even want to schedule a training session for your team. And one of the projects that we had here in Huntersville, we had photography. So all of our walls, as they were being built, there was a bunch of photographs. So it showed what was behind that wall, the way the med gas was run, the way the plumbing lines were ran. So that was really helpful, especially when you're trying to access something that's leaking. You know right where it's at. So if that plumbing line doesn't go straight up through the wall, it comes up 2 feet and over to the left 3 feet, and then it goes up. That's valuable information. So you're not removing a huge chunk of wall. So as we said, these closeout documents are very important.
Hey, can I add something to this slide? It's more of a plea to you all as facilities folks. So our team really does try to get all of these documents from the construction project pulled together so we can turn it over easily. But sometimes we may need reminding and we may need your help. And if something is missing, don't ever feel bad about saying, hey, where are these? We're trying to streamline the process for getting information uploaded to ATG. So it goes through one of our team members, and that team member can start to track projects and make sure information is coming in. But we know this is important information for you all as operators of space. So if you find something is missing or you really need something and you don't see it, please reach out, and we'll if we don't have it, we'll let you know what state it's in. But we really do need to work together as a team to make sure we get all this uploaded in the right spot.
Steve, you have a question?
Yeah, can you hear me?
Yes.
Google was able to fix my mic better than DPS. But so with the tower project at Matthews, they had me buy the flooring went out of was discontinued, so they asked me to buy the remaining stock so I'd have it. Is that in addition to what I would have had from attic stock? Should I still have? Would I have had some left? Should I have had some left over from the project in addition to what I bought?
You probably would have had a small amount,
Yeah.
probably not, a huge amount. It was probably a good call if they're discontinuing it, because what we've run into here in Huntersville is as they move in furniture, they move in different things in the stage. Flooring is one of the last things that goes in, and unfortunately, everything's running over the floor at the very end, and we've had damage done before we even moved in. So, if it's discontinued, you probably did a very smart thing and buy as much as you could.
Yeah, the simple answer is yes. I mean, the contractor buys a certain percentage of attic stock, and use some of it correcting mistakes that happened during the project, and then whatever's left over, the facility gets. But it's not always a guaranteed certain amount. So
Gotcha.
I think Matt had a question.
Dan, what's the name of that program you were talking about where you can the pictures and you can see it in stage? I used to use it at Mint Hill, and I can't recall the name of that program.
I wish I could remember what it is. I have not accessed it in ages. It was done on the 2012 bed tower expansion. And that was my only project that we used it on that I'm aware of. Todd Howard might be someone to reach out. I know I had it saved on my old computer, and when they changed it out, they actually did not translate, it didn't transfer over.
Is it
Sorry.
PlanGrid?
It seemed like it was something Vista. I thought Multi Vista or something. I don't, not that I use it now, but Seth, it might be helpful for Seth, down the road. I don't know if he's aware of that program or not. Maybe something his dad could get him into, but yeah, I couldn't remember it.
Dan,
Yes,
was it PlanGrid? Like you
That doesn't-
pull up the plan? That doesn't ring a
that
bell?
doesn't sound familiar. I know that the Vista sounds very familiar,
Yeah.
I don't know what that is.
but yeah, it was helpful.
Bluebeam.
Bluebeam is good where PDFs. I don't think it puts pictures in. Is that what you were saying? You have a plan and then it has pictures of the.
Well, actually, they went around and took photographs, and they labeled the photographs for like room 2245. And they took a picture of the head wall. They took a picture of the foot wall because that's where all the plumbing was. And then they took a picture of the hallway wall that included the bathrooms and their plumbing. And then it was labeled as such. Then they moved to the next room, 2246, and took the same pictures in the same directions. So that way you knew what was in those rooms behind those walls. For instance, if you're moving to head walls, we put head wall against head wall. So the med gas lines, as they come into each room, kind of showed exactly where they came down and where they were accessible. And then where the bathroom pictures were probably the most helpful, because we actually had like a small chase that we realized that we could access both rooms that were back to back, with leaks that happened with the shower valves. because of bad soldering or just just whatever bad fixture, whatever it was, we could access them without taking the tile off. So they were very helpful.
Yeah,
I
it
think
just,
we can. Oh, go ahead.
I was gonna say, it just shows, stages of construction and throughout the whole facility. I swear, I think it's called Multi-Vista, but I'm not 100% sure on that, but,
Yeah, I haven't accessed it in a while. But it was helpful above ceiling too, because they took stages, like when the electrical vendor come in and ran all their lines first, they had all that in there. And then the HVAC, they come in and took new pictures with the HVAC, overlaying on top of it. So it was helpful.
Todd,
Go ahead.
Todd teaches the class right after this, so if we can't figure it out between now and then, let's ask him.
Okay.
Okay, one thing our team likes to do is a 1-year warranty walkthrough. This really happens on large projects, and it typically happens after 1 year, just because of scheduling and things like that. I highly recommend if we're doing smaller projects and you guys are, or any facilities person is experiencing any kind of issues, that we do a warranty walkthrough with our design consultants and even our contracting partners, to talk through what's working, what's not, and determine, the causes of that, right? If it's an extremely harsh environment, or if it's actual materials we specified or design concepts that aren't working. You guys working in the facility are the best kind of eyes and ears to help those teams understand the implications of what we put in these drawings.
And then kind of on the heels of that there, we want to make sure we're getting our, engineering CD requirements. So that way each of the submittals, clearly identify those non-compliant features, if we find it through in the 1-year walkout. And as we get those, we make sure we're correcting them. And this could include, complete and accurate record drawings, and then final test and balance reports. Those final test and balance reports, DHSR is going to want to see those. We want to make sure that we're compliant. And then we also want to make sure that we're getting testing reports for those fire dampers. And that way, because if 1 year after construction, you've got to test all those fire dampers and make sure they're operational. And the fire alarm, you're going to be testing that quarterly. Water detection, refrigerant detection. One of the things that really got us in one of our programs or projects here at Huntersville was we changed out 2 chillers. Well, what was overlooked was that refrigeration alarm, because the alarm did not cover the new refrigerant. And we found that out in one of our inspections. So that kind of helped us, with that so-called commissioning, that it was missed. Even though that we had one of our chillers that had that same refrigerant that we just replaced, but the sensor that we had did not cover the new refrigerant. And the second part of that is also making sure that you get all this on your building automation system. We are really bad at not completing that portion. I know in Huntersville, what we always seem to miss was transitioning onto the building automation system, and making those plans with small projects were the worst, that we weren't capturing that information. And so when the technicians were going to those rooms and trying to make corrections, that stuff wasn't on there. So just kind of follow our engineering guidelines too, to make sure that is all accomplished. All right, I guess we've reached the break time again. It is 9:32, all right, 9:33. Let's look at coming back at 9:38. We'll take a little 5-minute break. All right. We're getting to that 9:38 location, and Steve asked a very good question right before we left. And his question said, when does the 1-year warranty time frame begin, especially when we are phasing the opening of different sections? That's a great question because that's really for debate. I know that when we had chillers that were operational before we took over, they pretty much put the timeline start as soon as the chillers started that startup. Air handlers the same way. So that's a great question, Stephen. I guess there's multiple answers.
Yeah, one of my concerns is we got a new chiller that we're not using because it's installed, but it's not tied into the system where we can use it, but it's been installed for like 2 months. Carrier's not going to really warranty it if it's not running. So we're having all kinds of issues around that, and I just don't want to get stuck with it. But then obviously with the phasing, I don't want to.
Well, Carrier's going to do the startup on it, correct?
They did the startup, and then we haven't ran it at all since they did the startup because it doesn't. The plan they had for our chiller plant didn't work, so they had to go back to the drawing board.
I
So
got
now we got a chiller that's been started up and it's sitting there, but we can't use it because it's not tied into. It's not tied in the way that it functions.
Yeah, I
So
would
that's
work
got
with
one
your.
like that.
We had the same issue. We had a heat recovery chiller that just never worked. It wasn't plugged in right. Now it's just a little mini chiller. I'm like, who signed up on this shit?
Yeah. Definitely work with your project manager in regards to that, because there could be, multiple answers to that. Like some of your equipment, your ice machines, obviously that's going to be when you start occupying the space. Roofs, that could be once you're covered. Chillers, once they start operational. So there's kind of a long timeline that could vary. Would you agree, Amanda?
I would say, yeah, I think my response was it's more art than science. So, I mean, different components of different projects are going to probably require that you do it at different times. But Dan's right. I would work with if you've got a design and construction project manager who's on who's leading the project, work with them to get that set up.
Okay.
However it needs to be.
Like, yeah, that I messaged Amanda separately. I meant to send it to the whole group. So
Did you? Oh, I see.
that's why I sent it twice.
I see. I'm not very technically savvy. I have
Yeah.
some it goes right past me. All right. So I get the fun job of talking about conflicting code requirements. So it will be short because there's never a confliction in the code ever. All the codes align. Psych. All right. So we mentioned before, we have to comply with lots of regulations, and the drawings are where we try to capture all those requirements as a tool to help folks build. So here's a list of some of the regulatory codes and standards that our buildings have to comply with. NFPA 101, Life Safety Code being probably so the one I'm most that and 99, the ones I'm most familiar with, along with FGI. But we've also got ANSI ASHRAE 188, the International Building Code, NFPA 5000, OSHA, EPA, HIPAA, ADA, and Novant Health Design Standards and Guidelines on there. So there's a lot of opportunity for us to get conflicting information from these codes. And so we really do rely on our design consultants, our architects, and our engineers to point these conflicts out early on in the process, so that we can make the decisions that make the most sense. Typically, we want to go with the most stringent code. That usually will save us a lot of heartache. But it is a conversation sometimes when we find things that are conflicting in the codes. And so conceptually that makes sense, right? We have an example that we're going to talk through to kind of help make it real. So we'll talk about smoke compartments. In the International Building Code, the requirement for a smoke compartment is 40,000 square feet. And Novant Health hired an architect who followed the International Building Code requirement of 40,000 square feet. You all might know that NFPA 101 does not require 40,000 square feet. Their smoke compartment requirement is, I believe it is 22.5, but y'all don't quote me on that. Yeah,
You are correct.
Perfect. So that's a much more stringent requirement for fire safety than the International Building Code. And so because our architect drew it, that's how it got built. And so that caused a world of hurt, right? So our push and really the responsibility we put on our consultants is to field these out very, very early on, so we don't have a mistake like that go all the way through construction documents and then ultimately get built and then require us to go back after a project's done or as it's getting reviewed by DHSR or whomever and really have to pay a lot of costs in redoing something that we could have easily caught early on.
Did Navon have to pay that, or wouldn't it fall on the architect or engineer for not catching it?
It's a hypothetical. We didn't do.
Oh,
We would never hire an architectural consultant that wouldn't. But
I gotcha.
we'll talk about like later in the class today. We'll talk about errors and omissions and who would hold responsibility for that. In that instance, we would put that on our architect, I think. So yeah, so we're going to open it up for discussion. And just sort of thinking about, if you've had some real world samples or examples, or that example, when codes offer conflicting requirements, how should these inconsistencies be resolved? What do we have to think through?
So we're having that issue now over our fire pump at Matthews, where the company who built the fire pump and installed it is looking at one code in NFPA, but our electrical inspector is quoting a different code. And so the codes kind of conflict, depending on how you interpret them. He's had this discussion with other fire marshals in other counties, and it has been able to convince them that it's okay the way they built it, but the Mecklenburg fire inspectors, a lot of is a little unique. And he's not accepting that fix, so it's creating problems and trying to get our fire pump to transfer on power loss in under 10 seconds.
Oof.
The manufacturer says by code they got 20 seconds in all, but the electrical inspector doesn't see it that way. So right now we're trying to see if we can manipulate the equipment to do it in 10 seconds, but if not, we may have to try a different fire panel, a fire pump.
Is the fire pump or the ATS that's associated to it?
I think it's the fire pump because they have a built-in safety to let the fire pump kind of wind down before it'll transfer the power. And there's some settings on the control, that particular control panel. I guess Todd Reed had a similar issue at FMC, so I'm hoping that he has the fix for us. So I just don't know if it's the same model.
Okay.
We can get it to 10.2, but we can't get it any closer.
Is that something we could have caught early on, like that conflict, or is that more of a?
I don't know. We test the fire pump ATS, but I don't know that we test it for 10 seconds like we do life safety and critical. So it's probably it was probably a existing condition that passed under a previous inspector, but this inspector's not allowing it.
We had an example back with a new construction project. We in Clemens, we were adding on to that facility, and the new Novant Health prototype at that time, we were doing what were called the wet rooms, right, where there is not a separate shower. The toilet patient room is the shower, and so we had the toilet, and then we had a drain for the room, and it made it through all drawing inspections and reviews. And then we had a building inspector that really got hung up on the plumbing. And I don't really recall which exact code he was talking to. I'm assuming it had to do with the building code, but not having 2 penetrations in the floor within a toilet room or shower. And so we had the toilet penetration and the drain penetration, and he was all up in arms about that. He could not wrap his head around a wet room concept. And then so what we ended up having to do was taking the toilet drain and making these wall hung fixtures to comply with only having one penetration in the floor. It was, we fought it and fought it and fought it, but it was his interpretation of the way a toilet room was supposed to be drained, and we could not win. And in that instance, I'm not sure that's something our design consultants could have foreseen as being a problem until it was a problem, but it was an interpretation that went against. So we ended up creating a chase to do a structure to hang all these toilets on, which was invasive.
It almost seems like there should be some kind of like appeals board with situations like that, where it's going to cost the company, potentially a lot of money to be just kind of over an interpretation of a code.
Yeah, you would think so.
Mhm. Yeah, and the one thing we hadn't talked about was, our DHSR reviews. We send all these plans into DHSR to be also reviewed, and they always make comments. So we've got a lot of people looking at these things. So hopefully the most everything will be caught, but there are always those conflicting. Which one do you go with? It's interpretation.
Good discussion.
Brian, did you have another question or something to add?
Yeah, I know with the fire doors, a lot of times I go up to the ORs and they have certain amount of information that they feel is necessary to post on the fire door itself, but they feel like that's a regulation that they have to follow by posting certain things. But then at the same time, we can only have 5% of the surface area covered of the fire door. So it's kind of a conflict of NFPA versus whatever regulatory they're going by to say, hey, we have to state wear the mask or whatever, the signage is. So I've kind of ran into that a few times.
Yeah, agree. It's funny. We're having a debate conversation right now with infection prevention and their precaution cards that they have in terms of where those go from a signage perspective. They're required to have the precaution cards. At one time we were trying to get everything off the doors, but now they don't like them so that they're not on the doors because people don't see them. And so now we're right back where we were with these big 8.5 by 11 sheets taped to doors. And it happens more than just in drawings, right? It even happens from an operations standpoint, how we get all these folks to work together to figure out what the optimal decision is.
Yeah, and I think we've got several facilities maybe running into the same thing that I ran into here at Huntersville with those caddies, because they protrude too far off the wall for the facilities that don't have built-ins. So, yeah.
We don't alcove into the.
Yep.
They sit on the main hall.
Hey Dan, if they don't come on any further than the alcohol dispensers, can you not use them or?
Well, if I'm not mistaken, it's 4.5 inches off the wall is allowed up to 72 inches off the floor. And then after 72 inches, you're allowed to come off the wall. But, a caddy is not going to be 72 inches off the floor. And what we did is we got them to right at 5 inches. And was our kind of our combat, because they barely stick past the Perel dispensers. And so we haven't been cited on it yet. We've had a couple inspections, but as of right now, everything is going well.
Thanks. It just came up with Matthew, so that's why I asked.
Yep. No, good question. we had a lot of discussion about that with several people. As we mentioned, those multidisciplinary teams, they're very valuable.
Our goal is to get as many of these conflicting codes solved within a drawing set so that we can deal with just the operational things that conflict with codes, because that is enough, right? I mean, that's our day to day. I think we have one more example of a conflicting code that you guys are probably very, very familiar with. And this has to do with storage. A hospital recently renovated and added storage rooms over 100 square feet. When designing the rooms, the architect went with the less stringent IBC, so they did not rate those rooms. The hospital found out after construction that if they have a storage room over 100 square feet, they need to follow NFPA 101 and make sure those rooms are have a 1 hour fire barrier. So this is an example where, you know, we think we would hold the architect liable for that. Hopefully our multidisciplinary teams, and one of the reasons we have all those groups working through design documents is, you know, the more eyes we have to catch some things, maybe we can at least ask the question early on, but ultimately the responsibility for that falls on our architect.
And the only thing I can add on all that is, you know, as Amanda said, we are highly regulated. We're number 2 in the industry, or out there for everybody. Anybody have a clue who's number 1 as being most regulated? Nuclear, exactly. So we're right up there with nuclear. How's that make you feel?
I was thought it was going to be airlines. We're more regulated than airlines. Nice.
Yeah, can you
Have you seen what's going on at Boeing?
right, well, and then, you know, airlines, they're more about like the customer experience in some ways, but they're very regulated too. We just have more AHJs and regulatory bodies.
Yeah.
Okay, so before we get into the scenarios, I want to make sure, can I get a thumbs up that you've been able to open the architectural set and the electrical set that was sent to you via Hightail? Casey, I know you're late to the party. Last night on Hightail, you received 3 sets of drawings. I don't know that we'll reference the mechanical again for the scenarios, but you'll definitely need the electrical set and the architectural set. So if I can get a virtual thumbs up or a physical thumbs up when you have both of those open, I would appreciate it. You do? Excellent. Casey, got you. Melissa, Gary, got you. Matt Daniel.
You said open mechanical and electrical?
Architectural.
Architectural.
Mhm.
Okay. I'll have it open in a second.
Thank you.
Mine are opening now.
Awesome. We're starting with the architectural. If you're trying to prioritize which one to download and open first. Even though that nuclear is more regulated than us, I would contend that they have it easier than healthcare. One of the largest nuclear plants in the country, if not the largest, is less than an hour from my home in Arizona. And they have their regulatory body has an office on property. So if you can imagine working in your hospital and you have a question for Joint Commission, DNV, CMS, Fire Marshal, and you could just walk down the hallway and be like, hey, question about this. Can you help me? That's what it's like for the nuclear industry.
Plus nuclear doesn't have patient experience, right? Like, so complying with regulatory is in and of itself what you need to do.
Mm-hmm.
Yeah, they don't hear complaints.
Yeah. Well, let's hope they don't, right?
Since we're located between 2 nuclear plants here in Huntersville and Charlotte area.
Yeah, let's hope they do not have any complaints.
What's disappointing and when comparing the airline industry to healthcare is they're more responsive than we are. to risk management. So, you know, anytime you see something going on with the airlines and bad things are happening, it's an immediate response because people can choose not to travel. People don't always have that luxury of not choosing healthcare. So unfortunately, healthcare is less adaptive than the airline industry because for the most part, it's not it, and people have to have healthcare. Okay, are we good? Everyone has the architectural drawings open? You ready to practice? It's gonna be so much fun. I'm excited for you.
Mine is still downloading.
Mine too.
Okay.
Bigger than I realized.
We're probably all on the same server.
Gonna blow
Hey,
it up.
in reference to that app earlier with the pictures and the video, was it Open Space? Was that it?
That doesn't sound familiar. I'm gonna
That's what
text.
we just used at Pender. Rogers Construction came through with a video camera and captured all the rooms so they would know, you know, med gas lines and stuff like that, locations.
We've talked about, have you guys seen Matterport on real estate sites where you can go
Yes.
and capture the whole space?
Yeah.
Yeah. We've talked about doing that. And I would think like even at certain times of constructions before everything gets closed in, so you can see what's behind the walls would be an excellent tool.
Yeah, that was the idea behind this.
We use it for training all the time. That and like a 360 virtual walkthroughs. We'll take a 360 image of an existing plant, and then you can navigate through, learn about the different equipment.
Yeah, I can see the 3D drawings being really beneficial instead of the photographs.
But we've talked about that. And I mean, that's a huge jump, right? To go from like in those 3D models, you can tag every single thing that's in it, right? So we'll take something simple like an air handler. We can put that in the model and then we can download all the manuals, all the maintenance records attached to that thing. So all you have to do is pull up the model, click on the piece of equipment where you're trying to do. You can see what it connects to. I mean, you can get a ton of information just from that model, but you know, somebody has to maintain that model and somebody has to update it when things change, and we'll get there, right?
Yeah, Amanda, the last project I did in construction before I came here was fully BIMmed like that. And being an electrician, you know, we're the low trade on the totem pole. So if our stuff's in the way, it had to be moved. And to have that tool to be able to stay out of other trades was very, very beneficial.
Yeah.
But I think mine's gonna take a while to download, but I can view it on the website.
Okay, awesome.
It's only halfway, so.
Yeah, mine's up now.
Okay.
Steve, you probably should have these drawings somewhere. Just saying.
Are they mine?
Yeah,
They are yours.
it's Matthews Medical Center.
Yeah, take a look at my energy plant.
You should be able
It doesn't look as nice as the pictures of FMC.
I'm sure it does. All right. So we're gonna start out slow, right? We're gonna start with an easy one. We're gonna use right now we're using construction documents, but ideally we would be using your record drawings in a real case scenario. First thing we're gonna do is find door replacement parts. And we're gonna assume for this scenario that you do not have access to a vendor who knows what doors you specified and all of that stuff, and you can't just make a phone call to get the information. Fair? All right. So facility engineer team member receives a maintenance request from a nursing group reporting a broken patient room door, which poses both safety and privacy concerns. We need to replace the door. So somebody goes and they observe it and they look at it, and we'll discuss. So after going to see the door and assessing what is wrong, which document would you reference in your record drawings to find the correct replacement part?
Are you mean from the index?
Say that again.
Are you talking about from the index? Where are we looking for that?
Yeah, so knowing what you know about a set of drawings and what information is contained in those drawings, where do you think you would go to find information about doors and door parts?
Doors to the interiors.
perhaps.
Architectural section under doors. It's
Door schedule, special frames and details.
yeah.
And so, so look, okay. So if we go to the door schedule, how do we know which door it is?
From the architectural drawing.
Yeah. So the first place you want to go, or look in your record drawing set, I'll probably go to the next slide. Yeah. You want to go to the floor plan and find the door number, locate which door you actually need to replace. And if you have your drawings up, this is hard for me because I don't know where you all are individually navigating, but the actual floor plan is A1.4C. And the door is in level 4, area B and C. And so we locate that exact door, which I think we are saying is door number 4125, maybe? Yes. So now we know what door. So now where do we go?
A 9.1 door schedule.
Good job. Yes, we need to go to the door schedule. And we need to find our door. And what does the door schedule tell us about this?
Which number's the schedule? I'm having a hard time zooming in on the website.
It's A 9.4 is the door schedule.
Thank you.
9.1.
Oh, sorry. So I noticed a mistake in our scenario, but we'll talk about it in a second. So we find out which door it is. What does the schedule tell us that would be helpful if we've got a door that won't that is broken and won't close?
What was the question, Amanda? Sorry.
I think Novant's having an internet outage.
Oh, I'm at home. I guess that's why I'm still on. I guess you guys
Yeah,
are
I'm
too.
at home.
I thought there's something wrong with my mic again because I kept asking a question.
No.
Good old DPS strikes again.
Oh.
I don't think I've ever felt more handicapped at a job than I do right now.
Oh, it's ridiculous. Lindsay, you might know this, or one of you two. Do you guys know of a website that is a little bit more in depth than Quizlet for the NFPA codes 101 and 99? So like studying for other exams, there's certain websites that you can go through and they give you really good Quizlets and really good.
Yeah.
But I went on the basic Quizlet and the questions were pretty generic.
Ashy has their own flashcards. I recommend those, but honestly, more than Ashy, I would recommend like the self-assessment exam. It's like
Yeah, I saw that.
Yeah,
Okay.
I highly recommend that more than the flashcards.
Okay.
Having gone through all the prep material and now teaching the prep material, I find that the actual test questions are very different than the ones that have been out there, especially for a long time. They actually revamped all of their certification exams a couple of years ago. So if you find anything that's older than like 2022, and most of it is,
The test has been rewritten since.
yeah.
Okay.
I think our life safety techs like Todd Stevens in Charlotte, I think he took the test questions on the NFPA site because he got his I think it was 101. But that was probably prior to 22.
Okay. Just thought I'd phone a friend on that one.
There's another program that also offers it. Let me look real quick. Are you taking the exam prep workshop?
I did that already.
Okay.
But now it's been too long. So I've got to I'd like to take the exam this year.
And it's the CHFM that you're taking?
CHC.
CHC. That one, I actually perform better on the CHFM than the CHC because so much of the CHC questions were around actual construction techniques.
Scenarios. Yeah.
Like when you're handing, and the pass rate is much higher on CHC because it is for practitioners. So if you haven't had to actually work on a construction site, you have to overcome that. But everything else is very academic, like the contract types and funding mechanisms and codes.
Y'all were in the course, weren't you? Didn't you guys both sit in on that course? Are you going to do it or no?
I
Undecided.
with CFM and this starting up, I just didn't have the time to go back and study for it.
Yeah.
I can't even get vendors paid right
It's
now.
still sitting
Well,
on
I can't get my
my
own guys
desk.
paid
I'm
right now.
trying.
I wanted to take it to have it, but I don't know. Maybe I'll review it and take a shot at it.
What's that, Steve?
That class we went to up at well, I guess I thought she was talking about that class we went to.
Yeah.
CHC?
Yeah.
Yeah, I haven't looked at it either. I want to, but it's like Steve said, as soon as this whole new Enforce system rolled out and then being in this class, like I haven't even had a chance to look at that CHC book.
It was really helpful to test on NFPA 99 knowledge, especially the med gas and essential electrical system chapters.
Oh, Casey's back. You get internet back into Casey?
So what, Steve?
You guys get the network back up?
Yeah, I don't know what happened.
Yeah, most of you guys got kicked off.
Which where we're at ain't very good anyway.
Oh, down there at the building.
Yeah.
Better than the hospital, I guess, because the hospital guys are all still off.
Well, Beeve just asked, we got kicked off, and when Lindsay said a lot of people did, I figured it was throughout the whole area.
I bet they went to the other feed that they have.
Did that happen to everybody or just me?
No, everybody who was on site.
Oh, God.
Only us dedicated people have stayed on.
I was just talking away. I was like, come on, guys, you know this answer. And nobody was answering me. And then and everybody's face was sort of frozen and then poof.
Yeah, I looked up and I had no internet. I was like, oh no.
Well, that happened to me in the coast too. I got kicked out.
Interesting.
It was all over. That's scary.
Oh yeah, I just got a security alert.
Uh-oh.
Well, you know what the positive to that is, guys? It means we're all one thing now.
We united now.
Remarkable together.
Remarkable together.
What's the security alert say?
However, information you exchange with this site cannot be viewed or changed by others. However, there's a problem with the site's security certificate.
Oh.
VexChat.
Well,
Hmm.
if you disappear, we know why.
Yeah.
All right,
Matt's been hacked.
are we ready to jump back in? Yeah, so we left off, we were at the door schedule. And do we see any information on here that's gonna help us replace any parts? Is that should I wait, Lindsay, or is everybody back? I'm sorry. I'm just
Most of us are back. Seth is joining now, so we can go.
Seth's just trying to milk it.
yeah.
Well, he learned that from his dad.
Hey, listen, I can hear now. Okay. Cute.
Cute. All right, so we went to the plan, we found out which door is problematic, we found the number. Our first step was to go to the schedule. The question is, do we see anything here that's going to help us repair the door?
What was wrong with the door?
It just said it was broken, so my assumption is it's not going to close, or it
No,
won't stay
it won't help
closed.
you.
The one mistake I found, it did say a patient room door, and then our drawing is actually, I think it was a storage room or something. So we're just going to assume no matter what it is or where it is, it's patient room door and it won't close. Privacy and security concern.
I saw somewhere it said it had parts, but I guess I can't.
Yeah.
I can't see the Zoom screen too good, but
I would argue there's nothing really in the schedule that's going to give us information about parts. It's really about the door itself, frame type. It does give us a hardware hardware set number, so we know what set of hardware it has. I would argue we probably need to go to a different document than the door schedule. Any clue what that might be? It may not be a drawing. Yeah, submittals.
Yep.
So if we go to the next one, next slide. Yeah, if you pull up the submittals and you see we have the door number labeled there, and it tells you door type, frame type, and then you can go and look up the hardware set that goes with that door, and you can get the manufacturer, the parts, et cetera, et cetera, et cetera. And from that, you can determine which vendor you need to call to order pieces of parts. Or, like we said, we would agree in this scenario, if you already know who your hardware standard vendor is, you could probably do that off the top of your head. But if you did not, you're new on the job and you don't want to ask anybody questions, this is one source of information for what is installed in your facility.
All right, now it's my turn. We're going to do the conduct electrical troubleshooting. So in ours, we are looking at ATSs. So in this scenario, the project team is in the DD phase and again faces the challenge of reducing costs due to exceeding the allocated budget. So they have to explore alternate options to save money. The project's architect and engineer firm presents alternate options for the originally mandated closed transition type automatic transfer switches. So I'm assuming they're going from closed to open. And when we're going from closed, they're a higher price because there's transition without interruption, and you also can do a little bit more of a sophisticated load banking. Or so we move to the next one. So the questions. So since the closed transition ATSs are more costly, the firm proposes considering open transition at a lower price point. The firm also proposes using isolation bypass options as part of the ATS design. All right, this is where you guys are going to have to do a little bit of discussion. So before moving forward with this design change, what should the team do to ensure compliance? Or what should they reference?
I'm gonna guess electrical codes.
Mm, I'm not sure that that could be one, but there's a particular one I'm looking for. The electrical code may allow both.
The Novant's construction standards.
Yes, exactly. So why is it important to ensure compliance in the DD phase, the design phase?
Probably how we've picked and choose our other equipment that's supported by the ATS. So I guess we need to make sure we have the one that's most compatible with our equipment.
Yep, that could be one, which would be related to what?
Cost.
Cost, exactly. So once you start changing one, you may end up changing a whole lot of other things, as in, that fire pump in Matthews. So yes,
We're taking donations.
there you go. All right. So next slide, it kind of shows referencing that. So if we reference the Novant Health standards, which guidelines would their project manager and electrician follow to decide if the open ATS are acceptable? And without referring all the way back, as we mentioned here, we're addressing the engineering standards. And if you go to section number 3, that would be the electrical systems. All right. Next slide. All right. So as a project manager and electrician review the proposed changes against the Novant Health engineering standards, concerns arise regarding the suitability of open transition switches and necessity of isolation bypasses, as you were talking about. The standards outline the need for ATSs compatible of maintaining seamless power continuity without interruptions, which that closed transition would offer, especially for critical medical equipment in the patient care areas. So according to our standards, a closed transition switch are compliant yet expensive. It's expensive. So if we're going to reconcile this, the electricians point out that while open transition switches and isolation bypasses might offer upfront cost savings, they could compromise the electrical system's reliability, safety, and regulatory compliance. Seamless power transitions or seamless power transfer provided by the closed transition switch is the necessary to meet the stringent requirements of maintaining the essential electrical system and ensure uninterrupted power to critical loads during those utility outages or generator transitions. So even though our standards are requiring this, if you looked into the electricals, Mecklenburg County or even the state, they may allow both. So that's where we get into this conflict a little bit. So if you were doing this as a facility manager, what would you recommend? Would you close or open? Anyone?
Closed.
Closed.
I would agree.
Yeah,
All right.
we don't want any delay in critical life safety stuff. So,
Yep. Yeah, most definitely. I've got a couple open transitions at a surgery center, and they're not fun to deal with. So yes, I would highly recommend finding other ways to cut the budget and leave the electrical system alone.
can you have both, Dan? Technically, like if you wanted open on normal power but closed on the critical and life safety stuff.
That's a great question. I'm assuming you could, because they would be different branches. They would just, the transition from your generator just, it might be a little bit different. Yeah, I'd have to refer to an electrician on that one.
Yeah, no problem. I was just curious.
All right, so resolution. So by reconciling with the engineering standards early in the DD phase, the project team avoided potential rework cost and ensured that the electrical system met the highest reliability standards required in healthcare environment. So this scenario kind of emphasizes the importance of balancing cost considerations with critical infrastructure, and we'll get into that balancing cost here in a little bit also. It underscores the importance of using that engineering standards to ensure all design decisions are compliant. And again, this is Novant standards, and we're using that standard to kind of help us construct our facilities.
Okay, I have another, we're gonna troubleshoot some electrical problems using record drawings scenario. And I'll be very transparent with you all. I know nothing about electrical distribution or engineering or any of that, but I do know how to read drawings. So, so I think it speaks to the power of knowing what's contained in those drawings and what it tells you and what you can learn just by kind of working through them. So, so our scenario is this. We've got a nursing staff reporting widespread electrical issues affecting some outlets and lighting within a third floor medical surgery unit. The affected areas are only throughout the third floor, and the impact is limited to normal power. So you're on the facility. I'll ask you, one, what's your first step? And then two, which record drawings would you be looking at to help troubleshoot this problem?
Justin, we got a hand raised.
Hey, Justin.
So for me personally, first thing I'm probably going to do is go to the third floor with a meter and start checking voltages at different locations to kind of see what's going on. And then, you know, from there, I would refer to the drawings as needed.
Okay. Anybody else? Yes, Steve.
So once we go to drawings, I'm assuming we do want to use the electrical drawings.
Yes, definitely want to use the electrical set of drawings. So let's or any other comments before we move to kind of first step? So yeah, so I think your first step, right? You're gonna go see what the problem is. You're probably gonna go to the electrical room and find out if there's anything immediately noticeable that you need to deal with. And so in this instance, the team responded and went to the electrical room on the third floor. And they looked for the cabinet marked normal power because it's after you've gone and done checked what's happening, you see it's only normal power. Opening that up, you can look at the breaker schedule and locate the right panel and find the main breaker with panel 3NBL, which is on the on position, but no power within the panel. So you know a little bit more now than you did before. So now's the time, like, where would you go look in the drawing set, and what would you do to quickly figure out how to resolve this particular problem?
You could see exactly, sorry, I'm raising my hand. You could see exactly what on the drawing, what exactly that panel feeds, and find out if it's affecting the whole entire panel or if it's just certain legs on that 3NLBL.
Which drawing is that we're going to, Seth? Or you can just tell high level, like which type of drawing. What are we looking at?
The floor plan, the electrical floor plan. I don't know what that is.
One line drawing.
Yeah.
Bingo.
Yep. So, yeah, so I think if we move on, we can we can check the electrical schedules and see where branch 3 MBL is listed.
Right.
Find which panels feed 3 MBL and find out what their what 3 MBL is operating, or what is it called, downstream. what it's making work. How about that? On the next page, you can see abbreviations for things that are on the schedule for receptacle, lighting, circuit. For folks that didn't know, but you would know because the third floor, 3 is for third, N is for normal, and then low voltage. And so you go to your next page, which is your line drawing that you're referring to. And pretty quickly you can see where 3 MBL is, that it's supplied from distribution panel 1 NBL DP, which is supplied by ATS, automatic transfer switch, NB, normal branch. And then we go back to our schedules and find the location of that distribution panel. And so for those of you following along in the actual drawing set, if you are, E714, I believe, is the electrical schedules. And it can show you that the normal electrical room is in room 1552. And from there, you can tell the breaker. Then we go to the electrical plan, showing the electrical room layout. And you can quickly locate that distribution panel. Questions? Does that make sense? Did we go in the right order? Okay. So the resolution for this one, your team's ability to navigate electrical drawings, decipher abbreviations, determine upstream and downstream power distribution, and pinpoint the precise location of panels became really important. And you did all that through the record drawings. So hopefully you can see the importance of being able to use schedules to efficiently troubleshoot problems.
All right, now we're going to hit the last one, that perform clash detection. So I got a question. Has anybody ever heard of valued engineering? I see a couple of head nods out there.
Isn't that all they do anymore? Is valued engineering?
Sometimes. All right, so this scenario, the project manager navigates value engineering challenges in healthcare construction. So during the construction project design and development phase, a budget challenge arises, requiring urgent attention from the entire project team. The initial project cost estimates are exceeding the budget, and the project team is under pressure to reduce cost without compromising quality and function. So value engineering in this is trying to find something that costs less, but offers the same quality. All right, so the architecture and the engineering firm leading the project uses a value engineering strategy to reduce cost. One of the measures they propose is the elimination of certain shutoff valves from the plumbing system within patient and non-patient care areas. So while this decision seems logical from construction, cost standpoint, from ours, maybe not so much. The removal of shutoff valves could have severe operational implications. So with that being said, We're going to go to the next slide so we can have our discussion. So the firm's decision-making process regarding the valve removal lacks a comprehensive review of stakeholder feedback and regulatory compliance considerations. Alternate solutions have not yet been thoroughly explored before settling on this valued engineering approach. All right, so now for you guys, before deciding on this alternative, how should the project manager move forward? Anyone? Anyone take a guess?
Maybe think about the resources you have on your team.
What do we always talk about this? Multi what?
Disciplinary.
Yes, all of our stakeholders. So even though it's going to kind of fall in engineering because it's an engineering standard, it could affect the entire hospital and areas around. So when should the team reference the plans to identify the changes of operational impacts? So we've got all our people together.
Before installation, one of the issues we're having here at Matthews is when they built it, they eliminated a lot of valves for cost savings. And now we're going back to do this new tower project and we're having to shut down the whole building instead of sections when we have to do water tie-ins and stuff like that.
Exactly. So
Yeah.
who made the final decision on all this? Remember that RC? Approve, recommend, consult, inform, execute, evaluate. So kind of use that whole, scenario that, Amanda referenced through our design and engineering standards, which is in one of the sections there.
Ultimately, I guess whoever's approving the money, all you can do is give them all the information you have to make the best decision. But we can't authorize to spend millions of dollars on a.
Yep. All right. So the engineering team. So we're going to look at the plumbing plans first. We're going to sit there and see exactly who are the stakeholders. So we realize that this valued engineering, it's going to affect surgery, pharmacy, laboratory, radiology, nursing, dietary, and some other key areas. So as we all come together and we're doing this multidisciplinary team, the surgery department raises the concerns about potential water supply disruptions, cleaning their instruments. And as we talk to the laboratory, they bring up, well, the need for precise water control and maintaining testing accuracy for the equipment. And I've actually been down that road. Their equipment is very sensitive. So any interruptions definitely could impact the way they operate. The nursing team highlights the importance of readily accessible water sources for patient care and hygiene protocols. Very valued. How long is the water going to be shut off? How long is that toilet not going to be able to flush? Dietary department underscores the necessity of consistent water pressure and quality for food preparation and sanitation. Without water, they're not cleaning anything. Their dishwashers aren't working. All right, so provide additional details on how operations could have been affected if they had gone forward with the suggested changes. And we talked about a couple of them. Anybody? if we're reducing the number of valves, how could that affect us?
I mean, just like Steve said, now they're having to shut down the whole entire wing or whatever instead of being able to shut down the floors.
Exactly. Increased shutdown area. Most definitely. More valves, you can kind of pull all those areas that are affected into a smaller area. Most definitely.
We got during the Scotts Hill construction project that's going on up there, they dug up the main domestic water line going to the building, and we don't have any way to bleed the system before it enters the building. So we had been changing toilet diaphragms and sink aerators that were getting clogged up because of the introduction of dirt into the system. So,
oh Lord.
Oh,
yeah, not fun.
wow. That's a chore.
Did you give Ken heck about that?
Who? Ken?
Ken?
Yeah, I need to. I give him heck all the time. Not enough, apparently.
So we talked a little bit about increased shutdown area. What about maintenance? Do you think it would affect any maintenance?
Yeah, absolutely. If you have a leak or you need to shut down an area, you couldn't do that without all those valves there.
Most definitely. So you mentioned a leak. Are those always planned?
Mhm. I would say never.
Exactly. So our emergency response could be slowed, couldn't it? And so with that emergency response, how many people do you have normally on staff?
Steve, he's talking to you.
What about resource allocations? May not have enough resources, may not have parts to readily, repair. So you're gonna have to shut down, like I said, longer and wider areas.
Yeah, you gotta be real strategic when you schedule them because especially like with water and steam, it can affect a lot. OR, surgeries, SPD, stuff I'm sure you guys have all had to deal with.
Oh yeah. And like Matt was mentioning, once you shut down, you're going to have possibly debris that enters your system. And now you got into a flushing protocol. And if you're flushing, now you're doing it in a much wider area.
Wasting water.
Well,
Yeah,
we'll call it flushing water management.
But I'm saying if you had the valves, you would waste less.
Exactly.
Yeah, our CT scanners keep going down because the strainers keep filling up with debris from all the shutdowns.
Yeah, we found some traps we didn't know existed that were covered up with insulation that we didn't know were there until started cutting stuff back. With something's blocking this. Where's it coming from? And finally found the strainers.
Yep.
Matt left you a present.
Yeah.
So yeah, we kind of covered a lot of areas. On the next slide, we kind of break it all down. So we had some very good discussion. We talked about the resource allocations, the quality and compliance, water quality, obviously, those increased shutdown areas, emergency responses, operational continuity, and then extended maintenance disruptions. So we kind of covered those and we talked about quite a few of those. So now with the resolution, when it becomes clear that the cost reduction can't be achieved without compromising critical operations, the team collaborates to determine where the shutoff valves are indispensable. So kind of figured it, okay, we can maybe reduce some of them, but maybe not all of them. So this scenario illuminates the long-term operational ramifications of value engineering decision-making during a design phase. It reinforces the importance of engaging all stakeholders and early in the project. And obviously, always cost-saving measures. We don't want to let them jeopardize operational efficiency or patient care standards, but we can always kind of possibly evaluate. And we may not need, in this scenario, all the shutoffs. We may be able to strategically place valves in areas that would, instead of having 10, you maybe have 5 instead of none. So definitely.
I think it's funny that we know all this stuff and we have all this information, but yet still we find things like what Steve is experiencing and what Matt's experiencing. I mean, it still exists. There's the deficiencies are still there, even though we know all this information.
Yeah, and I think to that point, it's that interdisciplinary team has everybody being brought in. And I think we're still learning on that. As Amanda had mentioned early on, some of this is all new to us. We're just now bringing everybody together. And I have to commend Matt Steen, for doing that. He's actually made a lot of our, walls and barriers that happen between our groups kind of disappear.
Well, and I think it does bring an awareness on your part that even though so let's say you're facing a current deficiency in a facility, hopefully these conversations occurred during whatever design and construction phase there was at that time. And at that time, the team had to make a decision, right? And unfortunately for you, that decision wasn't to make your life easier. It was there were other factors. So at least there's that awareness there that there was a reason those decisions were made. But yeah, I mean, I think the goal of all of this, and we'll probably get into the summary here in a second, but the goal of all of this is that, we have to really embrace that understanding that design and construction and the documents that come out of that are not wholly separate and apart from operations and maintenance of our facility. In fact, they're extremely closely intertwined. And the more we can engage with each other on the creation of those documents, and then also how they get utilized post-construction and during operations, is the better off we'll all be.
Anybody got any other questions or comments?
Okay, I'll summarize and then we'll open it up for a question. So I think I said most of this. I mean, I think the important takeaways from today, I apologize, I can't remember who asked the question first off about detail for these drawings. The goal for today was to just take away the big picture of what construction documents are. And I hope you got from it that construction documents are kind of living, breathing documents, right? They start from an area of no detail, they move to an area of more detail. Even while we're constructing things, we have to revise and edit based on things that come up in the field or whatever. And then those construction documents live long past the building of the building, right? The record drawings exist to help support maintenance and operations of the facility. I hope you got from us the importance of multidisciplinary teams and the need to review plans even at that early stage, preferably at that early stage, so that we can start to catch things then and don't develop a bad idea with more detail, but we catch the things early and develop good ideas with more detail. We definitely need all of our subject matter experts at the table. And as most of you are facilities folks, I mean, you do bring a very specific body of knowledge to the table when we're designing these. So we want to make sure we catch that. What's in a full set of construction documents, we talked about that with plans, details, sections, elevations, those types of drawings, specifications, submittals, risers, and diagrams. Occasionally we'll have 3D models. We're getting more adept at making 3D models constructible. But for now, our CD sets usually include 2D dimensional drawings and shop drawings. And then we talked a little bit about what we do in the conversations we have during drawing creation if we have conflicting codes, and how that is not a black or white issue most of the time. We tend to want to go with the most stringent code to help cover ourselves, but sometimes even that produces problems in the field. So just being able to have those conversations and think around the issues with the team to make good decisions. And I think that leads us to questions and answers. Or just questions. Those are always good too.
I had to dig in some old drawings here today. I don't know what's been going on here lately, but we had a shooting at the orthopedic hospital. Somebody shot from the sidewalk through a patient window where a patient was there, came through the window and went through the ceiling tile in the room.
Oh my gosh.
But I had to reference a 1978 window schedule and found the glazing details on it and the exact size and the curvature of the window, and I couldn't believe that I was actually able to find that.
That's pretty awesome.
Drawing, but they're
Yeah.
helpful.
Yeah.
And it was probably under what, about 14 other drawings?
Yeah. Had to knock the dust off of it to be able to read it.
That's pretty amazing. Well, I know Chip Pfeiffer and team have been working hard to get some of those historic documents on ATG.
Yeah.
What I have heard, I have not looked up a ton of them on there, but the ones I have, it's a difficult search engine to find some of that stuff. So I think we're going to continue to try and refine how you search for those documents on ATG so that hopefully you don't have to go blow the dust off of a paper version. You can find it digitally as well. But that's pretty amazing. Do we have any?
Were they shooting at the person or they just shot the room? Do you know?
They think it was a drive-by because I don't know what they were drive-by shooting, but they found the casing out on the sidewalk.
Damn.
Yeah,
Isn't
That's
that a
wild.
some
residential
70-year-old woman in the room up there. That's crazy.
I know, she could be pretty threatening, I'm sure.
Yeah.
That's like not a bad part of Wilmington, is it? Isn't it
It's
like a
not
little
that bad, no.
residential?
It's real. There's college kids that live across the street. It's a lot of college housing around the hospital. So
Oh my gosh.
yeah,
Goodness.
weird.
Well, thank goodness for 1974 drawings.
Yeah.
I think Presbyterian's our oldest facility, 1920. Who's on here that can correct me? 1923 maybe?
I was thinking it was 1908.
Really?
The original, the very
The
smallest
very first
section.
building?
Yeah.
Yeah. So those are some interesting hand-drawn, lovely drawings.
Yeah. And the only thing I would, add on to the summary, which we didn't really discuss, was I would challenge you guys that already have ATG access and team members to bring your team members into that same thing, because I don't think they know that this information is there. And if they're doing the maintenance, this could most definitely assist them in, and maybe a little bit more timely. And especially if they can read drawings, and I know a lot of our, technicians can read drawings, so bring them in.
All right, I'll see all of you in just a few minutes for our construction forms class. Make sure that you've downloaded and have access to the forms that I sent in my second email this morning, because we will reference those during class and you'll need them for your homework. See you soon. And then I'll talk to Amanda and Dan if you just have a few minutes.
Thank you.
All right, thanks.
Thank you guys.
All right, thanks, folks.